we started with a very general, moved towards the specifics of the local language, and now is an important block. Now there's a block on how does modern machine translation, and here statistical machine translation work, to give the audience a first intuitive understanding why data is so important. Yeah, because we're all after data, and so we have to communicate it a little bit. And maybe I do it from here. Andrea, if you could help me go through the slides. Okay, next slide. We just go around. So, okay, multilinguality, we know this, we go on. Okay, human language is extremely complex, efficient, elegant, and everything. One word can mean many things. One meaning can be expressed by many, many words. You can replace words by sentences, etc. So you've got many, many mappings, many-to-many mappings between form and meaning. Meaning is context dependent. You've got literal language. You've got metaphorical language. How can a machine ever do anything with that? Okay, it's really efficient, really complex, totally overloaded. For us people, that's why it's sort of like, so wonderful. But for machines, it's a nightmare. Okay, so next slide. What did we try to do first? We tried to rule this complexity. And this is sort of like rule-based. We tried to give an exact formula, a 24th order polynomial. That's very, very complex, huge grammars, etc., to formally describe natural language. In the form like big formula, sentence in, translation comes out. Doesn't really work. It's very, very complex, almost unmanageable. But the phenomenon is really interesting. We would like to do something with natural language. So in such a situation where we cannot give an exact computation or an exact mathematical description because it's so complex, what do? We turn to machine learning. So we learn patterns from past experience, which in our case is past translations, and we use these learned patterns to imperfectly approximate how to best make a decision in the present or in the future. And making a decision in the present or in the future is kind of like, in comes a sentence, how do I best translate it? Okay? It's important to realize that this is not exact, it's just an approximation. Okay? Because the whole thing is so complex that it's not sure whether we can sort of like, grasp it fully mathematically, but it's very useful. So what are the data? What are the past experiences that we're learning from? 3 kinds of data. Translations, text in the language. No, I think it's just two sorts of data, translations and text in the target language. Here you see some examples. Oh yeah, I can fly. So here's the German, here's the English translation. What do we do with this? Well, first of all, we need to find out which translations are translations of which other sentences. Once we know that, within those sentences that are translations of each other, we need to find out, use machine learning to find out which words in the sentence are translations of which other words in the sentence, and then we have to put it all together. And also we need the target. And this is non-trivial. Here you see already these are sentences and they're translations. And sometimes the translation of a sentence is just another sentence. But sometimes there are actually 2 sentences in the source that are translated into one longer sentence in the target. And sometimes it's the other way around. One sentence in the source is translated into 2 sentences in the targets. Non-trivial. But we have algorithms that can try to compute this. We can also try to learn this from data. So we can do this. So once we've done this, we have a sentence-aligned bilingual corpus. Okay, and here's another example of such a thing. And this is a Chinese restaurant menu. So here are the English dishes, and here are the Chinese translations. Kind of like, that's the result from sentence alignment. Now we're trying to find out what are the translations of the individual words. No linguistic knowledge whatsoever. Because these systems don't have any knowledge of linguistics. And let's just say we're interested in the Chinese symbol that translates egg drop. So how on earth can we do this? Because without any knowledge, any of these symbols anywhere here is as likely a translation of this egg drop sequence as anything else. So what do these systems do? Well, they kind of like, what they do is they look, where does the word occur on the English side? Then kind of like, if I don't have any linguistic knowledge, one thing I can sort of like bet on is that the translations of this word should occur in this line, in that line, and in that line. They can also occur somewhere else. But if they don't occur here and there and there, then we're in trouble. Yeah? Okay, let's try something. Okay, let's take this symbol. Is that a likely translation of this word? No, because it doesn't occur here and it doesn't occur there. So let's just drop it. Okay. What really happens there is that the probability that this word is a translation goes down. Okay, let's try something else. Is that a likely translation of this? Looks a bit better because it occurs here, there, but there's another problem. What's the problem? Occurs everywhere. Okay, so, translation probability goes down a little bit, okay, and I just delete these things here. Now, what about the next one? Yeah, that looks pretty good. Okay, and the system can go on like this. I can do the same for wonton. I can do the same for soup. That's probably the translation for soup, because soup occurs anywhere, everywhere. And you see, without any linguistic knowledge, the word has now learned, the system has learned which words are translations of which other words. Okay, now you all know that words sometimes translate into different words. It's not always like one word in one language translates into another word in another language. Here we have a sentence-aligned and a word-aligned corpus. So each sentence pair is a translation of each other. I love the boy, and the French translation, and so on. And each word is aligned with its translation in French, and I've color-coded this. From this information, I can now just compute a statistical lexicon. I can say this character, big I, is translated into J apostrophe twice, and once into J followed by an E. Okay? And I can do this for all the words in here, because they're sentence-aligned and they're word-aligned already. So I can compile a translation table. These are all the possibilities of translations computed on this corpus here. So for I have these two possibilities, and this is the likelihood, or the number of times it was translated into a specific form. And I can turn these into probabilities. And now I can use that information, which is completely automatically learned. No linguistics, no human involvement. And I can already translate a sentence that I've never seen. Okay, so here's the new sentence. It doesn't occur in my original corpus. I don't know anything, so I just translate word by word. So I translate the first word, I look up this table. The most likely translation is this one here. If I have no knowledge, I should just go by, how often have I translated something into something else. And I can do this for all the words here. And if I do that, okay, I get something very terrible happens. Yeah, that's an awful translation. That's terrible. But it might already help somebody, because it gives you predicate argument structure, who does what to whom. But it's not the end of the story, because it's not the only translation, okay? That's one translation. It's actually the most likely translation of this sentence given this data. But there's another one, if you remember that translation table. And that looks much better. And here the language model helps us. The language model tells us what is good language on the target side. Okay? It answers questions like, in good French, can it ever be the case that this J apostrophe is followed by this verb here? And if you look in our target size of the data, no, it never follows, and it should never follow, because it's not good language. So that solution is actually ruled out, and this one is the only one that survives. And so the output of the language model with the translation model, which have all been automatically computed, is a good sentence. Yeah? This is word-by-word translation. You can extend this, you can make this phrase translation, not just translating individual words, but entire consecutive phrases, so the girl, la fille, to the girl, à la fille, and so on. And then you already get a good translation even without the language model. Okay? And this is kind of like how modern statistical machine translation works. The thing to remember really here is the following, and that's why we're doing this. This sort of like, it's all about the data. If you train a statistical machine translation system on Harry Potter, okay, this is English Harry Potter, and this, I think, Czech or something like that, I'm not quite sure, yeah? Then that system, will be quite good at translating magic spells. But it will be terrible if you train a statistical machine translation system on Harry Potter and you try to translate weather reports. That would be awful, Or these public sector data, like this is a form financial assessment for family medication from the UK. It will be awful. And that's the point. That's why we're here. To come up with a good translation of this, we don't need Harry Potter, we don't need the EU parliamentary speeches, we need the data from the public services in the room here. Then we can make good translation systems that are targeted to their needs and that are hopefully a bit more useful than the systems that we can provide at the moment. Yeah. And that's the end of the presentation. Any questions? Again, this has to be adapted to the specifics of the local country. Like, there's a much more sophisticated version for Latvia. I believe that the public service audience in France is also very sophisticated about machine translation because they did evaluations already, and they have been thinking and working with these systems. So I think the presentation in France will also be more sophisticated than this, a bit more technical. But yeah. Okay, anything else? Any comments, any feedback? So the point that we're trying to make here is, like us, like people, this machine learning-based stuff is good at things that it has past experience of, that it has seen. So if you train on a particular genre then the system will be likely to give you good results for texts that are also in that particular genre. Okay? But if you train on Harry Potter, translate weather reports, no. Train on Harry Potter, translate magic spells, yeah. Likely to be a bit better. And that's why we're here. Okay, if there are no more questions, I think we go on to the next.